Hello, welcome to the video notes for lesson 11.4. This lesson is angle to angle triangle similarity. I know, that was a lot to say. This begins on page 21 in your notes packet. And let's go ahead and take a look at the learning target for this lesson. I can use angle relationships to decide whether two triangles are similar. So we're actually going to write a couple of things down. The first thing we're going to write down, if you have an older brother or sister or parents who were good at math, you can ask them about this. We're beginning something called proofs. So when you decide whether two triangles are similar, you're doing what's known as a proof. Or you're proving whether it's true or whether it's false. And remember, similar means, so here's the symbol for similar. It's kind of like a half mustache. Same shape, different size. Now you are not allowed to use this statement for your proof. This is just so you understand what we're dealing with. If you look at the picture below, it looks like we have the same shape but different sizes. What that really means when we're talking about a different size is that the side lengths are proportional. Side lengths are proportional. I'll just abbreviate that. And the angles are congruent, or they are the same. That's the big idea with same shape, different size. The side lengths are proportional. The angle measures are the same. Alright, so let's take a look at this example problem below. Wanda says she can prove that the two triangles are similar, and she is willing to bet her lunch money on it. Can you prove it? Alright, so what we are going to do is we are going to label our picture A, B, C, and then I want my corresponding angles lined up. So D, E, F. So angle A goes with angle D, angle B goes with angle E, angle C goes with angle F. Alright, so here's what we are going to do. Let's take a look at the first triangle here. So the measure of angle B plus the measure of angle C is going to equal something. Now you can tell angle B is 90 degrees, and you can tell angle C is 30 degrees. So when you add 90 and 30 degrees, you get 120 degrees. Now what's that mean? Well, since the three angles add up to 180, if I do 180 minus 120, I get 60 degrees for my missing angle. So the measure of angle A equals 60 degrees. Alright, now let's take a look at our other triangle. If the two angles that I know are angle E, so the measure of angle E, plus the measure of angle F, that's going to equal some number. So E is 90, just like over here. F is 30. When I add them together, I get 120. To find my missing angle, I'll subtract that from 180. And I get 60 degrees. Alright, so what does that mean? Well, that means that the measure of angle D is 60 degrees. Now, if I look at my triangles, the corresponding angles, angle A is congruent to angle D, and angle B is congruent to angle E, and angle C is congruent to angle F. Because the corresponding angles are congruent, that means these are similar triangles. So we're going to write our proof statement, our final statement, to answer the question. We're going to use something called dot, dot, dot. It's like 3 dots in the shape of a triangle. What that means is, therefore. Therefore, we can make the statement, triangle A, B, C is similar to triangle D, E, F. And make sure when you write this down that the angles or the vertices line up. A goes with D, B goes with E, C goes with F. Because, and actually we don't need to write the word because, the reason for this is corresponding angles we learned about corresponding in this unit. Corresponding angles, it's okay to use the symbols because we're writing in math, are congruent. That's it. So you just completed your first geometric proof. Alright, so let's go ahead and take a look at page 22. Key concept. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. This is a fact. This is something that we know. So if we look at this picture below, here's an example for us. And you can see these are overlapping triangles, and the picture next to it is where they pulled them apart. I'll show you the first triangle here, A, B, C. And then the bigger triangle is A, B prime, C prime. Now the reason why they didn't put A prime is because this A here is part of both triangles, and it's the same point. So since B and B prime are different points, that's why they have a different label. But if you look at the statement below, angle A is congruent to angle A, and that should make sense. Angle B, ABC, is congruent to angle A, B prime, C prime. That's these angles here. Notice they put a little double arch. What they're telling you is, everywhere you see a double arch, it's the same measure. Now, since this up here is just a single arch, it is only congruent to A. B and B prime are congruent. So since we know these two, then we can say triangle ABC is similar to triangle A, B prime, C prime. Alright, so let's apply this to some more examples. So we have two more at the bottom. Are the two triangles similar? How do you know? Alright, so when I look at the pictures, I've got triangle ABC and I've got triangle DEF. They tell me this angle, they give me this angle, so I know this is the same. I don't have angle D and I don't have angle C, so I can find them by just doing 180 minus whatever 77 plus 58 is. And if you do that, you will get 45. So this angle here is 45 degrees. Or I could look at the other picture and say, well, what's 180 minus 58 plus 45? And if you do that, you'll find that it's 77. So this angle here, D, is 77 degrees. So now what I know is the corresponding angles are congruent, so I know that they are similar. But let's go ahead and make a couple of statements. First, remember, I just need two angles to be congruent. I know, because I'm given the information, that the measure of angle B equals the measure of angle E. And it's given, it's 58 degrees. I also know, because I found it, that the measure of, I'm going to use this one here, angle C is equal to the measure of angle F. Now if you wanted to just say that they were congruent, just leave the little m off, and you could just say angle C is congruent to angle F. And we found that to be 45 degrees. So because I know that two of the angles are congruent, or two of the angle measures are equal, then I can make this statement. Triangle A, B, C is similar to triangle D, E, F. And the reason, corresponding angles are congruent. So angle A is congruent to angle D. Angle B is congruent to angle E. Angle C is congruent to angle F. Alright, we've got one more example, really quick. Can you conclude that triangle ABC is congruent to triangle DEC? Justify your reasoning. Well, I see this single arch here and this single arch here. So I know, so my first proof is, first part of the proof is, angle A is congruent to angle D. And the reason, it's given. They tell us. Somebody took the time to measure it for us and said, don't worry about what the measurement is, just know that D and A are the same. Now, we should also notice here that in the middle, this angle is also congruent. And notice I used the double arch. And when you label this, you can either put a number here and here to separate them, or, remember, we can use three letters. So this is ACB, angle ACB. C is in the middle because it's the vertex. Is congruent to angle DCE. And there's a reason I went in that specific order. And the reason for it, they are vertical angles. Remember, we learned vertical angles are congruent. Alright, so, therefore, triangle ABC, and this is important, the order that you write this, because they have to be corresponding, is similar to, remember, A goes with D, B then goes with E, and C obviously goes with C. So triangle ABC is similar to triangle DEC. Reason, corresponding angles are congruent. Alright, that's it for this lesson. Proofs can be kind of tricky for some people, so make sure you pay attention to this. If you had any trouble, go back and rewatch it or come and see me for help. Good luck, and we'll see you in math.